Hi new students, we are going to continue about the second video of matrices, and here we are trying to explain the linear equations, relation between the linear equations and the matrices, and we can solve the linear equations by using the matrices. But before that one, I'm going to solve the question with the known method, which is substitution method for us. If there are three equations like this, it means that we can solve if it is consistent from the previous one. If you remember, we are going to solve this one. So firstly, I'm going to the easiest one for me to use the last one. Then if I say y is equal to z plus 4, then I can substitute this z plus 4 in the previous two, and here, then I can solve the question with two unknown. Firstly, I'm going to decrease to two unknown, then I'm going to solve by using the other methods again. Then here, let me change the color, and 2x plus, instead of y, if I write z plus 4 plus z is equal to, this is the first equation, when you substitute y by z plus 4. And the second one is x minus, since it is minus, we have to put parentheses, z plus 4 plus 5z is equal to 0, it has to be. So I'm going to collect the like terms together and the known and unknown terms to one side, which means 2x plus 2z is equal to minus 4, it has to be. This is the first equation. As you see, 2x plus 2z. Then the second equation, first I need to open the parentheses. I'm going to go step by step. X minus z minus 4 plus 5z is equal to 0, it's going to be, which is equal to 2x plus, here, 2x plus 2z. It might be equal to minus 4. And the second one, x plus minus z plus 5z, it's going to make 4z, is equal to 4. And here I can use one of them, and I can here I can use elimination method here, or again you can use substitution method. Let's continue with substitution. Only substitution let's use, not elimination method, which means this implies that x is equal to 4 minus 4z. And I'm going to substitute here in that one. Again, I'm going to change the color. Let's change to this one. So 2x plus 2 times, I'm going to replace the x value, not the z. 2 times 4 minus 4z, it has to be plus 2z, it has to be equal to minus 4, which is equal to 8 minus 8z plus 2z is equal to minus 4. Here, when I add, this is minus 6 and minus 8 plus 2, it's going to be equal to minus 6z. And when you send to this side, this one to the other side, it is going to be minus 4 minus 8, which is equal to minus 12. Which means that minus 6z is equal to minus 12. Z is equal to minus 12 over minus 6. That's equal to 2. It has to be. And when you find the z value, by using the substitution, unroll the substitutions. When we unroll the substitutions here, we can easily find the y value and x value. First, I can find the x value. How? If z is equal to 2, I know that x is equal to, here I'm using this one, x is equal to 4 minus 4z, 4 minus 4z, which is equal to 4 minus 4 times 2, which is equal to 4 minus 8, which is equal to minus 2, it has to be. 4 minus 8, it's equal to minus 4, it's equal to minus 4. What about the y value? Y is equal to z plus 4. Y is equal to z plus 4, which is equal to 2 plus 4. So that's equal to 6. It's going to be. Okay, till this part we use the substitution method and we solve the x, y, and z values. I can write the ordered triple here. X value we found that's equal to, what is the x value? Here x is equal to minus 4. Sorry. Y is equal to, we found that's 6, and z we already found 2. So this is by using the substitution method, and I'm going to solve the question by using the row operation method and matrix forms. So I'm getting smaller here to have more spaces, but you already understood the operation here. That's why I'm going to leave like this, and I'm going to continue on the other side with row operations. Firstly, for the row operations, as I said, I'm not going to explain how we are going to do the row operations. Quickly, I want to solve the question. Later, when the time comes for the row operations, I'm going to explain what it is. But now, I want to show that you can solve the linear equation by using the row operation and matrices. So I'm writing here only the coefficients. So the first row 2, 1, 1, and 0. I want to change the color. Maybe it's smaller. Change to here, this color I want to use. Okay, then the second row 1, 1, minus 1, 5, and 0. And the third row, there's no x, so this is 0. The coefficient of y is equal to minus 1, 1, and the coefficient of z is equal to minus 1. And I'm going to here make this one here, the last one I'm talking here. This one is 4. As you see, I used only the coefficients. To do this operation. I'm going to go one up to use more space. That's why. Let's do like this. Then let's continue here. Firstly, in row operations, you can change the places of the rows, which means change row 1 to row 2, which becomes 1, minus 1, 5, it's equal to 0. Then, and I can do also like this. When I get this one here, the second row also, if I get, I'm going to explain the reason for that one later, as I mentioned. Row 3 to row 2, which means 0, 1, minus 1, and 4. Then the last one is going to be equal to 2, and 1 is going to be equal to 0. So I got this matrix into this form, and now I'm going to start to row operations. In row operations, you can multiply the rows by the other rows, and when you multiply by the other rows, the new row becomes the other row. I'm going to explain how it is. Like, I'm going to multiply R1 by 2, minus 2. Then I'm going to add to R3. Then this row, it's going to become new R3. Again, I'm writing here. Minus 2 times R2, R1, plus R3, it's going to be equal to new R3. That's important. That's going to be new R3 again. When you add to last row, it becomes the new row. I'm going to explain later the logic, but this is called row operation. Then it becomes like this. Here, 1 times 0, 2 times minus 1, 2 times minus 2 times 1, it becomes minus 2. And when you add 2, actually we are not writing here, sorry for losing the time. minus 2 times R1 plus R3, minus 2 times R1, which is 1, which is equal to minus 2. Minus 2 times 1 is minus 2. Then add to R3 and write to R3 this one, which means minus 2 plus 2, it's equal to 0. Minus 2 times 1, it is equal to 2, plus 1, it's equal to 3. Minus 2 times 5, it's equal to 10, minus 10. Then add to this value 1, which is equal to minus 10 plus 1, it's equal to minus 9, it has to be. Then this is going to be equal to the other rows we didn't do an operation, 1 minus 1. Here I have to do the same thing with 0, minus 2 times 0 plus 0, that's going to be again 0, that's why it didn't change anything. So this row we close like this, and this is 4, we didn't change anything here, and here it's going to be equal to 1 minus 1 and 5 here. Then we are going to close this one. As I explained in the previous video, we are going to try to get here 1 1 1 and the rest of them 0. That's why we are doing this row operations, as I explained before. So we are going to get the identity matrix. When we get the identity matrix, these are going to give us the results of the operation. So new operation should be, this is 1 now, so the rest of the rows, it should be equal to 0. That's why R1, R2 plus R1 should be new R1, and minus 3 times R2, because this is going to be 0 and this should be 0, plus R3, it should be new R3. Let's do these operations for each term in the entry. So what it should be, directly I'm going to add 0 plus 1, it's going to be equal to 1. 1 plus minus 1, because it says R1 plus R2 plus R1. So 1 plus minus 1, it's equal to 0. Minus 1 plus 5, it's equal to 4. 4 plus 0, it's going to be equal to 4. So this is new R1 now. We didn't do an operation by here. This is equal to minus 1, and here it is 4. And here down, it's going to be equal to 0. And because minus 3 times 0 and plus 0, it's going to be equal to 0. Minus 3 times 1 is equal to minus 3, plus 3, it's equal to 0. Minus 3 times 1 is equal to 3, plus minus 9, it's equal to minus 6, it should be. Minus 6, here it should be. And 4 times minus 3, it's equal to minus 12. Minus 12 plus 0 is going to be equal to minus 12. Here, I'm sorry, I have text here. Mistake C. Okay, let's continue here. Now I got 1 0 0. This is 1 0 up and down 0, and now I have to get this one 1, then the rest of them is 0, because I have to catch 1 1 1 on the diagonal of the matrix. That's why it seems that I'm going to divide the R3 by 6. R3 by minus 6 I have to divide to get here 1. Then I'm going to continue to row operations, which means I am rewriting first two row, which is going to be equal to 1 0 4. It's equal to 4. Then 0 1 minus 1, it's equal to 4. And the last one 0 0 1, and it's equal to 2, which means actually here I found the z is equal to 2, but I'm going to show that the others also it's going to be the same. Here let's firstly start with the first row. Since this is 1 and the first row is 4, I have to multiply the last row by minus 4, then add to first row, then I will get here 0. That's why minus 4 times R3, then add to R1, then that row it's going to be not old row, but this value it's going to be 0. So that's new R1 it has to be. And here directly when you add them, R1 and R2, if you add them, this is going to be 0. This is R3 plus R2 is going to be new R2. So here we are going to do this operation one by one. Since these rows are 0, these entries are 0, not rows are 0. These entries are 0. They are not going to affect the operation. But let's start with the... by the way, I have to say this one also. The last row, it's going to be same. That's why it's going to be equal to these values. Then I'm going to keep this row now here like this. Then I'm going to multiply the last row by -4. -4 times 0, as you see, it's not going to change. -4 times 0, it's not going to change. When you add 2 up, it's not going to change the value. 1 and 0, this is going to go. And -4 times 1, it's equal to 4. Then this is when you add to this one, that's equal to 0. Okay, we got this one. And -4 times 2 is equal to -6. -8, I'm sorry. -8 plus 4, it's going to be equal to -4. And here it's going to be equal to, directly we are going to add. So 0 plus 0 is equal to 0. 0 plus 1 it's equal to 1. And 1 plus -1 is equal to 0. As you see, R3 plus R2, R3 row plus R2 row is going to be new R2 row. I'm writing the new R2, and this is 2 plus 4, it's equal to 6. As you see, I have complete. I have get the identity matrix here. Actually, identity matrix is our main aim. When you get the identity matrix here, the results here should be -4, 6, and 2 should be solution of here. As you know, this is x. This is 0, 0. So this is x plus 0y plus 0 z is equal to -4. If you remember how I wrote this one from these numbers, and it's, as you see, it's going to be x is equal to -4. By the same way, you can say this is y, and y is equal to 6, and z is equal to 2. Okay, so I know that this seems complex than the previous solution. We are not going to use for 2 by 2, for 3 by 3 for the row operations, but as you see here, by using the row operations also we can solve the matrices. Thank you very much for listening, and we are going to continue with the next video.